Hello, good morning. Good morning, everyone. Uh, you can see my screen or not? Because afterwards, I'm going to use the whiteboard behind. There's a whiteboard now. So can hear my voice or not? Is it clear or not? If clear, can you please comment one? Yes. Okay. Good. Okay. I'm going to do some adjustment. Okay. We are still waiting for at this moment. Just now I saw 24 students, but now left only 23 students. It means that because I think maybe the internet connections are not very strong. For those who are maybe have a problem of internet connections, but we wait for a while. Wait for a while for the rest to come in, because I just informed in the WhatsApp groups. Okay. Okay, let's see. I noticed that like Alimsa also just left. Maybe the connection is not good. Okay, I have okay, I joined back already again. Okay, I have shared the this attendance form. I combined today where I combine the attendance form in one. And what I'm going to do is I'm going to do some changing of today lectures. Means that I'm going to start with precast first, because then only come back to this pre-stress. The purpose is I need to use a whiteboard, okay? Because if let's say the weather is not allowed, because I'm at the balcony, at my balcony. The whiteboard is at the balcony. I have write something. If that say the weather is not okay, then I will going to shift inside. Okay, it's heavy the whiteboard, so therefore I'm stuck with precast first. And also the other reason is because today we are the precast. The main purpose is focus on the precast joint. Because my my final year project student Liu Bi Hong is here, so so that I can also she can get something okay, related to her FYP job, FYP works. Precast joint the this corbel, okay, corbel, okay, corbel design. So that's why I decided to start with this precast concrete first of the lectures, and then only follow with the pre-stress. Okay, follow with pre-stress. Next week is the last week. Next week is the last week. It's not mistaken. Next week is the last week. Said next week the lecture is not very long. We will see how what we did not cover, and we are going to discuss the this the final exam, the process, and also the projects. Today we have start with project also. We talk a little bit about the projects, where the submissions, the submission of the projects, and afterwards, then only start with precast. I think because project yesterday I already share something already. The projects. I open some of the file first. I see who haven't come in. Okay, so all are ready. All are ready. Maybe we can talk first. Waiting since I still got suppose still got 6 students. All together suppose plus 28 plus 2. 28 plus 2. I drink something. Because it's a long lecture. Yesterday we have in the faculty we have morning the whole day. I'm here actually. Morning got a meeting, faculty meeting from 9 until 1 something. Then afternoon 2:30 until actually I left about 6. I think 6 something. The briefing. Okay. From the university. Came to the faculty to give the briefing. about the means the the assessment of the staff. I just frankly speaking, uh, how good is the lecturers if let's say in just in teaching only, just teach how good you say, okay, we teach very good, we deliver very good, we give you a lot of information, we try our best to teach you all that able to use in your future. I tell you, is for us actually is we just get a very low mark only. There's actually a lot of things that is which is um, they are because university now I look at the situation now is all like we got ranking, we got what, and it's a game lah, it's a game lah, huh? That's why it's a game, it's a game. I say it's a game. You can partner with something you want to get a promotion, and so on. If not, those who thought they want to join in academic, want to join in university now, the actually a lot of thing lah, huh? A lot of thing is not. If you are really capable or what, like you are very like that kind of thing, and if you just like let's say just teach like this, I tell you, you may even the assessment, the marks even not pass, you cannot get the increments of the salary even can be set also. Okay, how good you are just in teaching only. This is what I can see lah, huh? Okay, that's what I can see. That's why you may found that actually some of the lecturers, or I maybe not here lah, huh? You say, hey, the lecturer actually like always cannot find and not do the job, but get the promotions and so on, that kind of thing. Okay, there are many lah actually. So that's why there's a problem. There's a problem. So I don't know the rest want to come in or not. Still so many people not coming yet. Okay, and we have yesterday. Today we are not rushed, so I try to cover as much as possible the main thing that all the syllabus, so that we not next week we just relax to discuss some of the thing. Okay. Okay, I talk a little bit about the projects first. I have shared the informations of the projects. Wait, let me open the file. Oh, somebody just joined. Okay, Safika just joined. Okay, Safika, good morning. Okay, projects. Projects. I look at the submission of projects. Okay. I have decided that the submission of the projects is on the 26th, 26th of January. Okay, the project submission is on 26th of January. If you refer to that I have already shared in the Google Classroom, and also the in the WhatsApp groups. Okay, means that 26 is on Tuesday. Tuesday, 2 weeks from now, about 2 weeks from now, means until midnight, 11:55. And you have to the documents or the material that you need to submit in for the project is the first is a technical report. Okay, it's a technical report. So technical report, you may ask, what are the contents? What are the contents of the technical reports? So technical report is, you see, in my technical report, not necessarily to be very thick. Not necessarily to be very thick. The information must have, you look at the rubric form. Both rubric form are about the same because I do one, then I create another one, and based on the task that you need to do. Okay, based on the task that you need to do, you look at you divided 3 parts. The last one, CL3, basically is based on your video presentation. Okay, your video presentations. So we don't have going to have ask you, call you for Google Meet. I think I try to make it simple lah, huh? Make it simple. Submission on 26 until midnight, 11:55 p.m. Okay, means that almost up to Wednesday lah, huh? Okay, and this is after really after your is during your this study week. Okay, during the study weeks, huh? Okay, so technical reports, the contents not run away from your introductions. The introductions are no need to introduce too much on, for example, either precast or pre-stress. Okay, the introduction I want actually more on the background of the project. The introduction is the background of the project. So when you talk about background of the projects, basically is the background of the projects is about the project that you are doing. You have to describe. Okay, you have to describe. Okay, the background of the project. Afterwards is it should be follow. Okay, you some of the information you may create by your own. For example, the bridge. Okay, the bridge. You can elaborate more. Okay, you can elaborate more about the bridge, the location, where is it, and so on. Then after that, you must discuss more detail about the bridge, for example, the span and so on, and your proposal of your proposal of your this pedestrian bridge. Then you may have some of your elevation view and so on. Okay, that you're going to propose how it look like and so on. That is more a little bit like the I can say is architecture view, this kind of things, the architecture view. So afterwards, you are going to the next one, the topic you should, because this is the same when you write a technical report, whatever technical report. Afterwards, you will focus on the your structural parts really. Okay, you focus on the structural parts really. Okay, the structural parts cover what? Cover your system. From there, after that, your system, your structure system. Then you must have plan view of your structure system. You have your side view if you want your cross section view and so on. And then your design parameter. Afterwards, you will design your design parameter. And after this, only follow with your this is follow with your calculation. With your calculation, the detailed design analysis and calculation of the pre-stress elements, of the pre-stress elements. Okay, then afterwards will be your detailing, and then you may do a summary or conclusions, and you have any references, then you can just list out your references. Okay, so is it clear or not about the technical report, the contents? So if you're clear about the technical contents, for both are the same, both subjects. One is the factory precast. Okay, this is the pre-stress. If you are clear, can you please just comment one before we switch to another things? Okay, so those who are involved, I tell you, those who are involved, yeah, they are actually the groups. I think got 2 to 3 groups, not many especially like the 2 to 3 groups actually got the I think 2 groups only have the ask me, and even we have the Google Meets, have the Google Meets, we have the Google Meets and discuss the projects, the pre-stress and precast together okay. They have also, they have, when along their process they are doing, they have actually asked me also what they get and so on. Is it okay or not? Yeah, very good, very good. I tell you, I can see your efforts, but the rest I'm not very sure. The rest I'm not very sure. Means that you learn something. I will try my best actually to entertain you all lah. If that say the time, even if that say you ask me when is it and so on, I will tell you. Even got one is at night, is it? At night we have discussed. Usually at night I sleep quite early. Okay, at night I sleep quite early. But night I think it's a Friday night. Friday night after my badminton games. Okay, come back 7 something. I have a dinner that I told them is about 8 something lah, 8 plus. So we discussed about I think 1 hour plus. I think almost until 10. Okay. This is a learning process. This is a learning process. You see, if I look at like the student like this, I know them. Although sometimes I can't remember their names and so on. But when they are if let's say I have some opportunity or there's some inquiry and some opportunity, okay, I will introduce the students that I know their background are good. Is it their backgrounds are good, so that I know I can trust, so that the student, the candidate that I'm going to introduce will not will not affect the image of our graduates or our university, especially our FCAPs, okay, graduated from FCAP, and also myself also. I don't want next time when I introduce one, then next time if got the performance is not good, then next time the I mean the boss or the company, my friends, dare not to ask me to introduce some more. That's why you see so many years already. There's actually got few company always, if that say they require the engineers and so on, they will come to me and ask me to recommend. Okay. What time? Why? Okay. Ming En, you have any problem? Because I have attend for another class. Okay, it's like this. Until 11, you have another class, is it? Like this, no problem. We can actually adjust. If that say like this, the pre-stress we can adjust to afternoon. Your class is until what time, Ming En? 11 until 1, is it? Around and what time the class? I thought 11. Why you have another class? Ming En, you get on the mic actually. I have foundation engineering 2 to 5. Then 11. Oh, okay. You because I've still, and how come if like this okay, you are taking pre-stress, is it? Never mind lah. If that's it like this, I can go back to pre-stress, no problem. Okay, I can go back to pre-stress. I try to cut short, no problem. I can start at pre-stress, no problem. I can start with some a little bit of precast first that I have drawn here. Okay, then we can, after this we can go for pre-stress. Okay, we can go for pre-stress, no problem. I No problem. Then we see how we can go after this. Only continue with precast. Okay. Never mind. We start with pre-stress, but we start with a little bit of precast. Okay. Start a little bit of precast that I have. The very important things that I forget to tell you, forget to guide you, but I did not show you the example. I give you the concept, overall concept, which is very important. That I did not teach. Even like few days ago, one of your, actually my former students, your senior very graduated many years ago 2000s plus, I don't know at least plus minus I think it's about 15 years ago. I think plus minus about maybe uh, third, about 13 plus minus about 13 to 15 years ago. I can't remember which batch contacted me. He was my former FYP students and my former SYP students. He was work in China before also. Okay, and then after this, now it's actually as a manager as a manager. Okay, now in KL. okay, in KL. Okay, now as a manager's precast on precast products. One of the very established company, and that actually a lot of precast. One of the I mean the established and international company, like I can say precast products. In KL, he is the manager now. He is the manager. I look at his so he snapshot his card and snap and send it to me lah. He's the manager many years actually. Yeah, another friend actually last time very good friend in Malacca. I got that one still from time to time we still got keep in touch. But yeah, I was lost with him many years already. Okay, I think many years already, at least more than 10 years. Okay, but I got heard the news from his friends, his former classmate. Then he come to me actually is ask me his friends also, his friend in Mua is a developer, want to get the approval, because especially what you did in your this what to say in your IDP, sorry, IDP, okay, that you need to do IDP. Your stage is under the earthworks stage, which is the conversion already approved from different type, from a title, different title. Other titles want to become a development title, so that one is under the SBKS stage, Selah Barik Kurnia Semula. So that one is local authority. Very depending on the local authority, the requirements and so on, and your connection with the local authority must be good if you want to get the approval very fast. So the French developer in Mua required to get a very quick approval So that's why come to me and ask me. I have long time not in consulting firm already. So I have lost some of the contact but I got asked, introduced to him, to my friends and so on and after that he tried to get some information, and that I got recommend from there, recommend. Okay, so even after this we got talk. He got last 2 days he got actually WhatsApp me and so on. Then we got chit chat and so on. Okay, early morning 6 something we got chit chat and talk about, even you see like here I say, oh, my youngest son is in and then my not youngest son, my eldest son, then my eldest daughter is in this studying also in KL. Okay, then I say my daughter is studying e-marketing. Say, oh, if got any help, he can help. He can help if basically he knows somebody is doing business, this kind of e-marketing, online e-marketing business in Malaysia and China especially. So say, just send me the resume. I say my daughter haven't finished yet. Okay, my daughter haven't finished the study yet, just the first year only. Okay, my eldest daughter in the first year. Say, oh, see from here actually we help people, and they will help us also. Okay, they will help us also. Even he sent when chit chat and so on. Long time no, we did not contact. He say something here. We say something here, but now my WhatsApp is a WhatsApp. Okay, I think my connection is not good. If they say my connection is not good, can you please let me know? Okay, can you please let me know? My WhatsApp is not good. My line sometimes, because I use the booster, or because my phone problem. My phone is my phone just now is restart, is it? Okay, now already okay. Okay, my phone just restart so now all the messages come in. Okay, my phone is start back. Okay, I have to really. So you see like this even also the same thing as I mentioned, your studying in university, I always say face-to-face physical face-to-face study come to the campus study is very important. I actually not encourage. I not prefer to do online. In your case maybe still all right because you all the not you have just affected about 1 year lah, huh? But you see, when you study in this university, not only the knowledge, the friends, okay, you will get a lot of friends, and especially for your next time for your future career and so on, you have this kind of contacts. Okay, you have this kind of contact. He mentioned like this. He got a message after that we chit chat lah, huh? Okay, he say, I really grateful to have good lecturer like you, which changed my life during I study in Quito, Batu Pahat. So his time is Quito lah, huh? Okay, his time is Quito, still in Quito. Okay, it means that we feel actually we just did our parts only, huh? Okay, we just did our parts here. Okay, so but they still remember us. Okay, okay, they still appreciate what we have done. Okay, we have actually but now I noticed now there's not all lah, huh? Some students or even not even like I can tell you like even now got not Malaysians, it's international students I have supervised before, and also even got the international students come last time the form first degree here, after that continue to master and the PhD and got the PhD already. Even they come to me and even ask me PhD that time how follow my class before and ask me some like topic what to do. Then I got proposed. I got proposed to him, and it's this a good idea in my mind you can do, and I know this material have the possibility to get to do in the research. It's when people don't know what is form concrete that time, actually I have already touched about it early year 2000, 2000, early year 2000, people don't know what is form concrete yet. Okay, you ask the construction also don't know, and the even the here also locally with also the form concrete blocks we also don't have aerator block. We have start ready, and after that I did some research and noticed that actually the carbonation is very high. So I give him an idea. I say, actually now if you go towards the green, especially like US now, the new presidents are coming another few days. Okay, the Biden is emphasized on the green. Okay, he is emphasized on the green. So and many countries are actually very concerned about the carbon footprints. Okay, want to reduce the CO2. Then a few years ago, I told him, I say, this one you can do actually. You see, we can, if let's say a country like, let's say some country like even in Australia, if you want to make something and you want to, for example, let's say you want to establish a factory, a factory that required will produce the CO2. So you have to pay the tax. You have to pay more. Or one way, actually, you can composite. You can do something composite. So I say, if let's say I have a material, construction material that I can evaluate. If I construct how much of meter square, okay, I can evaluate that. Say I can quantify how much of CO2 it can absorb. So next time, if I produce something, let's say I produce a product, I make a product that is going to emit how much of how many tons of metric tons of the CO2. Then I say, okay, like this, I can contra not paying the money by building something. Okay, for example, let's say I build a house, I conduit something. So I can say, oh, I use this material to build the wall that it will absorb. Okay, you can quantify and can absorb how much of CO2, okay, how much of CO2, so that you can actually control something like this. So the idea is actually for me. I tell you, even recently he's going to present something. I think in what I don't know whether you all got join it or not. Okay, you all got join or not. But if I look at somebody is even finished and so on, but did not. I just I mean it's although it's not appreciate means actually is the idea is from us and even give the uh, advice and so on along the study, but at the end I don't know, even not showing that, oh, maybe the in the thesis or what, and knowledge and so on, this kind of thing. But we are not actually expect this kind of thing lah, huh? I mean see, different person have a different what, some person they are more towards their what to just look at their benefit, what they can get without after that they have get something, they may forget some the person actually they are not appreciate this kind of thing. Okay, before we start, yeah, all are here already. Maybe MCO already now raised. Today is first day in the Chinese calendar, the 1st of December lah, I can say 12 month, the month, that last month of the first day in Chinese calendar. After another this month, okay, about 29 or 30 days, it depends, I can't remember, will be the Chinese New Year. Okay, so we can't, this is the second time of MCO. Okay, we can call it an MCO2, but the MCO2 this time is the way is not like so so straight, I can say lah, compared to the first time. Now even I can see over, you say I can say most of the business is still can allow to open, most of the business is only reduce the time, because many, when you talk about manufacturing, constructions, the services, some of the initial services, I can say all actually include it also. And even the kindergarten and also the nursery, you're allowed to open, allowed to open. So I don't know how good is it with that, say with like this, whether it can really can reduce down the COVID or not, but hopefully it will make it. And also yesterday also without science have declared darurat, declare the darurat. I don't know you all know about it, what is darurat or not. Maybe you if you read all this you have to be aware we also don't not very sure actually, but you can read from the newspaper, from the social media, actually darurat in this one is in, you go back to the constitutions, perlembagaan, you can see what actually when mentioned in the perlembagaan, if that say darurat only can be I mean approved declared by the Agong Yang di-Pertuan Agong, means that suggestion by the Prime Minister or Cabinet. Okay, then Agong agree, and usually it's because of the we can't control something, for example the security, and if that's say even a disease that we cannot control and so on only. But you see now we already have the use MCO already. Why lah? Mean justifications, mean personal view and so on. Is it we need to have a darurat or not lah? But the when darurat that time, what is actually like this here? I understand that is we can call in the law here now the especially the Prime Minister can create the ordinance. Ordinance is temporary law, something like this, and without get to debate in the parliaments and so on. For example, that say I say okay, now you have you have few houses. Okay, no, now is hospital not enough, so we can take your house. Okay, we say I want to use your house, you cannot say no, and you cannot say no. Okay, you cannot say no. But if they say like it's not under darurat, we can actually, this is our right. We not necessarily must you need to get my approval, only can the house only can for temporary pass it to you and to use for your things. Okay, But Darurat, it can implement this kind of things without any get the approval. Okay, it can implement. You can make and implement the law and also enforcement directly. Means that no three power divide already. Like we got parliaments, okay, then we have debates and so on. This kind of thing. No, already now, no. Okay, so these are the impacts. If use it properly, okay. If let's say it's not use it properly, it's just for politics and so on, it may misuse and so on. This one is just your I mean some of the informations, your knowledge to sharing, maybe not related to one, because you are the future generation. You all must look at the things, okay? You all must look at the thing and read more, and especially the current situation and so on. Okay, not just what in your field only I can say read more and so on we love this country. That's why if you love this country, you have to really know the history. I'm not saying that my history very good, okay, the culture and so on. Okay, so not only listen to one side only okay, not listen to one side. Okay, so now let's start I talk a lot already so I'm going to if you look at here we start with a little bit of this whether is it can see clearly or not. Let me adjust a little bit I don't know whether you can view it clear or not Let me, because at the back here is the air compressor. Okay, it's an air compressor. So I adjust a bit, I bring it front a bit to cover this part. Alright. I don't know whether you can take the load or not, the chair. Because it's not very stable, It's not very stable. Okay. Can you see clearly? If you can see clearly, can you please say yes? Can see or not? Okay, let's start now. A bit. Okay, so now, okay, good. Okay, you can see. Okay, let's start now. You can see my this one. If let's say you got anything, you just on the mic and tell me. Okay, this is precast. Have precast beam. Have something missed out. Okay, you can based on actually is a Euro code or British standards also can. I give you an idea. You can snapshot. Or after this, I can take a picture and send it to you. Also can, or you can just screenshot. You can screenshot. Okay, if let's say we have a beam, series of the beam for precast. This is normal RC precast. But okay, consider a composite composite precast beam. Composite precast beam. Okay, so we have a beam. Let's say the subjected to the uniformly distributed load. Okay, and the length is L, and the cross section is something like this. Okay, this is the cross section. And if you look at the if let's say it's a composite beam, these are the precast we make from in the factory. Okay, we make in the factory, and the bar we extrude out. Okay, the link here we are extruded here. Okay, assume that these are the precast slab. Okay, these are the precast slab. Okay, we're going to put on it, and these are the bearing. Last week we studied the bearing, how to calculate what is the bearing ready. Okay, previously, and then we got the gap and we can pour the topping, cast in situ. So this one we can become a composite, Okay, this one may be for those who are not taking the pre-cast, uh, it's just extra knowledge, extra knowledge. Okay, so previously I have teach you how to design the beam already. Okay, with few example using the design table. Okay, using the design table. Still remember or not? Okay, those who are, if let's say you haven't in the project, you can do this way for your beam. You can use this way to design. You can use simplify this way to design. Okay, simplify the design step like thing like this. Remember, this one important. Okay, so these are the precast beam, and so now assuming that the precast beam now, this is the H1. Okay, then the topping, the precast slab until the topping top here is a H2. Okay, this is a H2. Uh, and we look at now, in this case now, the loading stage. When design the main reinforcement that time, you look at the loading stage. We can divide it into two stages, is it? So if you look at, you have to imagine the loading stage. You see, when you design anything, if there is a station that is abnormal or not like usual, so you have to know how the load is going to apply, how is the load is going to apply, and how it's going to behave. In the previous example, actually almost the same thing. It's only we are using design chart. Okay, but if that one is more go very detailed, we go very detailed, follow exactly, very detailed. But we can simplify something like this. Okay, simplify something like this. Okay, that in the actual constructions, this is a precast beam. Okay, we have erected. Assume this we have erected already. Okay, we have erected. Then after that, we are going to plot it. We are going to support this one at the end, both end, is it? We are going to support at both end. But if we got in the previous example, we got plot and unplot, is it? But now this one is assume unplot. It means that the plot only at the both end only. This one, the beam actually is just supported on the maybe the column and so on already, okay, or the main beam. Then the precast slab sitting on the beam, okay, sitting on the beam. And so you see, during the construction, we got the first stage, the loading is what? The precast beam itself, also what? And also the cell weight of the floor slab plus the cell weight of precast slab, is it? Cell weight of the floor slab and plus cell weight of the precast slab. This one plus this one. That you can include together lah. Yeah, precast slab and this one. Okay. After that, we pour it, the concrete, and it hardened already. It become a composite, is it? It become a composite. So it becomes stage number two. Stage number two. So in the stage number two, actually what we consider is only the live load from the floor plus the dead load from the floor. Means on the floor, from the floor system. So we can divide in the first stage is all GK. You can consider as like in the example using the design table, is it? Using the design table, if you give extra loading during the construction load, we can add some inside here. We can add here. If let's say during the construction, people may work on it and so on, is it? But maybe not really like a bit. So if we can ignore it, let's say you want to ignore it, it's okay, no problem. So in this case, we consider in the first stage, W1 is only the cell weight of the floor slab. Okay, cell weight of the floor slab, plus the cell weight of the precast slab. That's all. Before you harden the floor slab here, including the topping, including the topping, we cast in situ. Means that, but we haven't hardened again the strength before it form the composite action. So the second stage is really form the composite action already. Means that only we consider the live load and dead load from the floor. Okay. So when we design, we need to design what? Design for the fracture, is it? Design for the fracture. Stage number one, you look at stage number one. In stage number one, we'll get 1 AS. Stage number one, the D here, the effective depth, we based on H1 to calculate the D, to get the D1. D1 basically the H1 minus the cover minus the link minus the main reinforcement, half of the main reinforcement. And this is, sorry, not link, half of the main reinforcement, the main. Okay, the main reinforcement. Okay, so we get the D1. Then you can calculate M1, the moment due to the loading stage number one, W1 multiplied by L square over 8, is it? Then you can design as usual, calculate the K1, K is M divided by what? M divided by 0.87, M divided by BD square FCK, is it? Then calculate the Z1, calculate the AS. Okay, this is for stage number one. After that, stage number two, you get AS1 already. In this case, you get the AS1. So in stage number two, because the whiteboard is a bit small, so in stage number two, okay, in stage two, we are based on calculate the D2 already. We based on in stage two already, it means that the composite already taking in place. Okay, composite already take in place. So when composite already take in place, we use the what? The D2 is use the total here already. Means is the D1 just now we calculated, we minus this one plus the H2 plus H2 we get the D2 means start from here. Consider H1 and H2 already. And then you can calculate the M2 moment, M2 based on the W2. The live load due to the floor plus the live load from and the dead load from the floor. Okay, from the floor. Then you can calculate K2, Z2, AS2. So this is based on the D2. Then the fracture reinforcement, the total reinforcement that required is the AS is AS1 plus AS2. Means that from stage number one plus stage number two. Okay, so this is the I can say is the easier way to do when you design for your, if you design for your this beam if you design for the beam. Okay, if you design for the beam. Only here we did not take composite or what, we did not take as a French beam or what, this kind of thing. No, we still consider as a rectangular. Okay, we still consider as a rectangular. This is the B lah. This is the B. So then after this we have to check for the shear. Is it design for the shear? So I draw this one for the shear, or I drop this one okay, for the shear, let's say I play this one for the shear reinforcement, for the shear. Okay, so for the shear, you here got just now got W1 already, is it? And W2. So the total W is what? W1 plus W2, is it? So you can calculate the design shear, is it? If simple total is W1 plus W2, okay, this is factor. You see, this is already factor here. Divide by 2, is it? Divide by 2, is it? So after this, what you need to do, you just follow as what you have learned, what you have learned in your RC design to check for the shear. You have to calculate what the VR D max, is it? VR D max here. Then you can get the theta here, is it? Follow the equation there. Then you have to calculate the AS. Then you have to calculate the here I drop it here. It's not stable. Sorry. Wait. Oh, it's very heavy because I just use a chair to support it. I want to get it because the compressor there is better. But because it's too far, a bit not very, view is not very good. I hope it will stand good. Huh? Okay. But okay. I hope you will. Oh, I just simply use the timber to just hang it only. Then you can calculate the shear, like the shear link. Okay, the shear link is what? ASW over S. Okay, equal to what? VED. This kind of equation 0.78 FYK. Okay, got the D. Yeah. Remember here now design for the link we based on D2 here. Means that overall D here already. Okay, overall that here. We based on overall that and cotangent theta, is it? From here you got the equation to get the theta and so on, is it? 22 or what in the range, the 22 to 45 degree. Okay. Then you have the minimum length, is it? Then you can calculate the minimum length, like what you have learned in your RC lah. The minimum length is what? Is ASW over SS is equal to, is what? 0.08. I can't remember. If you check the equation, I can't remember the equation already. FCK and B W over FYK. And all these 0.75 D, no greater than 0.75 D. Okay, so you see, you get this one already. You get this one already. Then you can check the deflections. I think deflection all will pass one. Deflections and so on, so will pass. It's only now you look at, actually there is if you really want to go detail here, if you want to check one more things, which is, it may not critical, it may critical, is the torsion. It's the torsion. You look at the beam, this beam here. Okay, if you look at this beam now, I clean this one. I clean this one. You look at this beam. Okay. When we install that time, when we do the installation, or it can be, let's say one side, do the installation. Maybe this part we install first, this one we haven't installed. Or during the service at time, maybe here got full with load, here the room is here. Let's say here full with live load, here just the dead load empty. So what happened? It's the torsion. Okay, it's a torsion. It's a torsion that we need to consider, something like this. So the torsion here, if you look at the situation now, is what we need to do is something like the beam. If we take out the beam only, it's something like we have one side we have to put as what? P minimum, and one side we put as P maximum. Is it? Where the P minimum is what? 1.35 dk, and this is 1.35 dk plus 1.5 qk. Okay, so roughly these are the things that you in your projects, you can use this one to calculate, but you no need to check. You just stop until the deflections only lah. Deflection, you take the whole wall, take as a rectangular section to design it only, to check on the deflection. Torsion you no need to consider lah. Torsion you no need to consider, but because in your RC design, you did not study torsion. But you can from here, you want to get a torsion, basically, you can arrange the loop something like this. This is 1.35, this is 1.35 plus 1.5. Then you here will create what? This force will create clockwise moment. This force will create anti-clockwise moment. It's symmetry. So basically, you will get the based on the center here, based on the center, then you will get the torsional force, and then you can design to calculate the torsional shear stress and design and check for the reinforcement actually. Check for the reinforcement only extra, whether we need extra reinforcement or not to resist the torsion. Okay, but in this case, maybe not very critical. So, any questions or not? I have to do adjustment, a bit of adjustment. We go back to, I do adjustment a bit. You let me take the time to do adjustment, rearrange again. Oh, sorry, Nabiha, just now you asked me to record. I did not read the message. Sorry, I did not. But you got a screenshot, I think should be all right already. Okay, you got screenshot, then should be okay. So I adjust first the whiteboard. Okay. Then we go for pre-stress because who just now say got the class. I hope that 9:30 by 11 sure that we can finish. Then only we continue with the pre-class again. Sorry, just now I forget to I forget to do the what I forget to do recording. So if you understand, can you please comment too that what we have discussed, especially for those who are learning the this precast and you are going to design your beam. You can use this way to design. Okay, we can combine actually you can combine BS, combine Eurocode like this. You is using Eurocode also, using all the equation, Eurocode equations. Okay, so you can combine, okay. The rest okay or not, you can understand. Okay, good. Okay, if you can understand, you just comment too lah. I go and wash my hand. Okay. Because why I like to teach from here, sometimes actually is no interrupt, no interrupt because children are downstairs. If I last night I always from my downstairs, but downstairs sometimes the children also want to use the computer. They want to study. When I teach, also I'm going to talk, so may interrupt their study also. So therefore, it's okay with internet. I worry just the internet only here because internet, the modem and the booster is at the downstairs. Okay, so okay. Next week we've got time. We can talk after we finish everything ready. We can check like we can actually open them on the mic and we can snap do a screenshot to all on the camera next week, then to get for us to memorize it lah, huh? We can share, and the last lectures, okay, we can share all together. And next week I will explain to you about the final exam. Okay, I will explain to you the final exam. If you look at the going to the author, I have already I already upload the question, but it's already scheduled it in the author, because for undergraduate compulsory to use author, but I have going to do some adjustment, but I will inform you what to do lah. Okay, so we in block ready sector, then we have the composite. Okay, composite and the horizontal shearing. Okay, this is what we're going to study. For today, to finish out, actually I want to finish out. Okay, so I'm going to do recording okay, just now I forget to do recording. Okay, so are you ready? If you're ready, then we can continue to the pre-stress. So please commentary, then we are going to start now. Okay, good. Okay, so I'm going to share the screen and do the recording, Okay, good morning, everyone. Okay, today we are going to finish out the syllabus of pre-stress concrete design. I believe I can finish out. If cannot finish, then next week we'll extend a little bit. We'll extend a little bit if let's say we are not able to finish. Okay, last week we have looked at the design of deflections. Okay, deflections of no, last week is the en bloc design using the core practice methods. Okay, and I have given you the one take home quiz, and I have already marked the quiz also. Okay, mark the quiz for pre-stress concrete design. I have marked the quiz and I marked the assignment number 2. The assignment number 2 that I use is I take this Krishnamurti Magnum diagram, okay, as the assignment number 2, and take home quiz, second quiz. It means that for test 1, test 2, only test 2 I haven't marked. I hope that by next week I can finish out all the tests to mark it. I will mark it, don't worry, because you have do your job already. Okay, this is my job to my responsibility to mark it. I cannot just simply leave it and give you the marks like this only. Okay, I cannot just timbang kati only based on how much you write only, but it's how the how the accuracy I have to consider. Is it? So that's why I will read and mark your test. Okay, mark your test. Okay, today we look at the deflection. We have left only 2 small topics: deflection and composite constructions. Although composite construction is considered as the last topic, but it's just a small topics. And in the composite constructions, I'm more focused on the horizontal shear. I will focus on horizontal shear. Okay, deflection of pre-stressed concrete structure. After we have designed everything, okay, we have to check the deflection. Is it? You see, like normal RC design. Also, we need to check the deflections under the serviceability limit state. But now in pre-stressed concrete, how are we going to check? Okay, how to check? Okay, because we have one element, is the pre-stress. The effects of the pre-stress will cause what? Will cause the outward deflections, is it? So this one we have to take into account. And pre-stress, you have to see, you have to remember they have the pre-stress loss. Okay, for long term also, the effects of the creeps, especially the creeps of concretes, will also affect the properties of the concrete. The deflections is always, if you look at the equation, go back to the empirical equations. Deflections, the equation is that say a beam subjected to an uniformly distributed load W. To get the maximum deflection, based on empirical equation is what? The delta equal to 5 WL power 4, is it? Divided by 384 EI. E is the Young's modulus of the concrete, and I is the section properties, is it? Okay, so the E of the concrete will change actually. The E of the concrete will change if subjected to a permanent load that due to the effects of creep. Okay, due to the effects of creep. So the E of the concrete will reduce if got the creep effects. So therefore, we need to check for the short term and check for the long-term deflection in pre-stressed concrete structure. If you compare to the normal reinforced concrete, that we did not consider this criteria. We did not consider this criteria, the effects of creep. This is what sometimes like I have, maybe for those who have followed my RC design class, RC1, I think, I have mentioned before, last time I have involved a project that my friends, my former colleagues, already retired. Dr. Lee, he have been, his friends is asking help that go to the case that go to the court case that we are representing the contractors. Okay, he was represented the contractor because the developer not paying the money, saying that because of the construction works, because due to the fault of the contractor that caused the got cracks of some on the floor or on the beam, I can't remember, on the floor, is it, that therefore the developer doesn't want to pay the money, say is the brain to the contractor. It's an existing buildings, existing shop lot, I think maybe shop lot, then converted to become a hotel hotel. So they are going to do partition wall on the floor and so on. So then I ask my help. I say, okay, like this, we are defend the contractor. Is it? Contractor say that he has followed all the drawing. He has followed all the drawing to construct. So how is it happens? So I use back this actually exactly because of I use FEA, finite element analysis. I use LUSAS to simulate, okay, and to get the layout and the extra wall that's put on the floor, irregular braces, and look at the overall stresses and look at the deflection, what effects if the apply the load like this, and due to the creep effects of the creep effects because of the existing structure, the concrete have subjected to a permanent load for a long period, and the E aspect based on some literature and so on, some value, the E I can get the reduced E, and then to calculate what is the effects of when apply extra load that will cause the additional deflections, okay, will cause the additional deflection and compared to the allowable deflection. This is my point. This is my point to justify it, that the crack is not due to the fault of the contractor. It's due to the nature effects of the properties and so on. So if you look at this kind of things, what you need to do, if you go to this kind of court case and so on, is the developer will employ his consultant, his expert. So contractor will employ his contractor. My colleague or my friends actually, Dr. Lee is good in concrete. But I don't have PhD but I have more rujak my more rujak. But many people actually asking me, even the PhD people doing maybe already got the professor and so on. Even when doing their PhD at time, ask me how doing simulations, ask me to teach and so on. Okay. yeah, I help them to do that. Okay, and guide them to do how to do that in the FEA and so on. So you see, I mean, if you come to detail, sometimes the contractor or the engineer, they maybe they have already forget, they did not consider all this. Okay, and go to the court case is how you convince the hakim. Okay, how you convince the judge, this lawyer, hakim we can say, to judge you are representing. So the lawyer may ask this kind of funny thing, how you can convince them, and you the proof not only convince, to prove it you are right, only you will win the case, is it? So all those small things that you look at here now, it is important. It is important. Okay, so deflection is one of the important consideration in service in SLS. If you got excessive deflections, it may cause what? Sagging of the floor to the roof. If that's say the roof and so on, if the structure is supporting on the beam or what, if that's say the beam got excessive deflection, it may cause the roof, that's say the roof to have somewhat failure. If that's say deflect too much, may leaking. If that's say the roof, if we are so worried, if that's say in the roof leaking is the problem, we are here rain, then water come in, then a lot of problem already. Okay, so and also the will damage the partition, finishes, and so on. Okay, so this kind of this is a problem with that say we have excessive of deflection. Therefore, we need to what? We need to control the deflection in within an allowable limit here. Okay. So in pre-stressed concrete member, deflection under a given load can be eliminated entirely. It means that in pre-stressed concrete, is the good thing is why? You look at the last point here. Usually deflection in pre-stressed concrete occur in an upward direction. It means that pre-stress, if you pre-stress it, okay, we pre-stress it at the bottom, basically we are going to push it, is it? Pre-stress with pre-compress. If the tendons, the reinforcement is putting below the neutral axis, and we provide this kind of compress, you have an upward deflection. You have provide an upward deflection. Then you apply the load on top, service load. Then you are going to have counter it. You can counter it. Therefore, the deflection in pre-stressed concrete sometimes is not critical. But although we say like this, we must also control, even in the transfer stage, the upward deflections. We have to make sure that you must be limited. If that's too much, if that's you build a bridge, just a small width only, but your structure is counting like this, is it? So how you're going to fill it out? Too much of material and so on, or it may be dangerous. You can't see the other side. Okay, and even too much of upward also will cause it cracking of the fracture material on it, such as the finishes and so on, and the services may leak and so on, the joint and so on. So therefore, we need to control the deflections here. So deflection of pre-stressed concrete, we can divide it into short-term deflection, and also long-term deflection. Some sort like we have the loss of the pre-stress, we can divide into short-term and also the long-term. So under the long-term, actually, we can group it under the uncracked or cracked here. But if you look at it, we have simplified we are just focused on here. Uncracked here is under class 1 and class 2. Crack is under class 3. Okay. Short-term deflection. Now, just now, here, based on here, we got short-term and long-term. So now we look at short-term and long-term. Short-term occurs due to pre-stressing force before long-term losses. Okay. So occurred due to pre-stressing force and only the cell weight. So we consider only the cell weight and the pre-stressing force in short-term deflection. And it occurs immediately upon the application of load. Okay, caused by elastic deformation of concrete in response to loading. We are going to have 3 examples. I think we have 3 examples. Okay, then long-term deflections. Long-term deflections here. Okay, Long-term deflections, the long-term deflection under service load, okay, we got the service load already, is due to the effective pre-stressing force, okay, after long-term losses, after we have long-term losses, and the gravity loads, okay, gravity loads, okay, and the long-term deflection takes into account the long-term shrinkage and creep movement. So here we have to consider, especially the creeps, okay, the creeps. The permanent components of the gravity loads are considered in the effects of creeps. We'll see how in the example, how to calculate in the example. So now you look at the deflection in the curve, something like this, short-term deflection, immediate, something like this. Then after this, we are long-term. After that, we will consider time-dependent deflections. So total here, we get the total deflections, okay, for long-term. Deflection of pre-stressed concrete beams, okay. And so we can calculate the deflection based on the stage of loading, transfer and service, okay, transfer and service. For each stage, the deflections due to pre-stressing and external load are determined separately. So we are going to calculate the deflection in different stage differently, okay, differently. Then after that, we only combine. And at the different stage, we can check also the allowable also. Various methods can be used to calculate the deflection. Actually, you have studied in your mechanical material, you have studied in your in your structural analysis. There are many methods we can use to calculate the deflection, such as what? Macaulay method, double integration methods in mechanical material. Okay, moment area methods, you study also conjugate beam methods, principle of virtual works. Okay, I believe at least 3 methods you have studied. Double integration, Macaulay, we call it. You are more familiar with Macaulay. Moment area methods, yes, you have studied in your mechanical material. And another one is principle of virtual work. Principle of virtual work, I think in your structural analysis, you may study in the structural analysis, especially in the to get the truss. In truss, you have a S mu L over AE, is it? In truss, okay, we use the virtual work methods as the based on the virtual load. We apply a virtual load, 1 unit of load, and so on. Okay, how now we look at the short-term deflections, the equations. I mean, short-term deflection, the equations. Equation actually we use for short-term and long-term actually the same. It's only this one is due to vertical load. Okay, due to the cell weight, due to the service load that we apply. Okay, and this one you are familiar, you can get from anywhere to get the equation, is it? Like what you have studied in your steel design. Okay, steel design, if we have a center, we have a point load at the center. This at the center, this is the maximum deflection occurred at the mid span. So the maximum, if let's say there's a beam simply supported, subjected to a concentrated load at the mid span, this is the equation PL3 over 48 EI. If let's say we have a 2 concentrated loads, okay, 4-point bending here. So this is the equation. And if we have a uniformly distributed load, especially here in our case, okay, so 5WL power 4 divided by 384 EI. And this you have really familiar. Then how about in pre-stress? In pre-stress, we have a set of load also, equations, a set of equations. And depending how we arrange the pre-stressing tendons, the pre-stressed steel inside here. So camber, these are all camber, means that because of the camber here means upward deflections, because the deflection, the tendons is put below the neutral axis of the cross sections of the beams, so we cause the upward deflection. This, if it is a straight tendon, so negative here we put as the upward, positive we put as the downward here. Negative here is the upward. So if it is a straight tendon below the neutral axis of the cross sections, so and this is the E, so this is the equation minus PE L power 2 divided by 8 EI. And it is when it is a deflected tendon, okay, and this is the equation. This is the equation. Okay, this is the equation. When it is a parabolic, deflected, but it is in parabolic form. Okay, so this is the equation. This is the equation. PL square over 8EI. Okay, bracket E plus 5 delta over 6. Okay, delta is this one. Delta is this one. Maybe you not put here. Delta is a mixed span. Why is the delta here? Okay, this is the delta here. E is the N here. Okay, is N. Means that this is the neutral axis of the overall cross section, and how far the from the here. If that say this is the positive E lah, okay, if that say is over here on top, it will become negative E lah. Okay, your E may be, sometimes you say your E at the end is 0, so this one may be 0 here. Okay, so now we look at an example. Okay, hopefully by we try to finish by 11 because who make uneasy got plus. Determine the mixed span deflection of the beam shown below. The first one, at transfer with an initial pre-stress force of 6,800 kilonewton. And second case is under an imposed load. Okay, this is under pre-stress. Okay, after this, we have applied an imposed load of 30 kilonewton per meter run when the pre-stress force has been reduced to 4,500 kilonewton. Means from 6,800 reduced to 4,500. And take the cell weight of beam 11.26 kilonewton per meter run, and the I, okay, second moment area here, okay, 0.06396 m power 4, E 28 times 10 power 6 kilonewton per meter square. Okay, this is a Young's modulus. Okay, so look at here now. Here E is equal to 0. This is the delta, is it? Okay, and this A, is it? 8 meter. The beam has 24 meter. Here at the mixed stand here, this one have a E equal to 260, 260. So you look at this is the equation, delta lah, not E lah. And here we put as a delta. So E here now we are 0. E here is 0. Okay, E is 0. Okay, so we are going to use this equation to calculate due to the pre-stress, the camber due to the pre-stress. So cell weight loading now, be the cell weight at transfer, what we need to consider. Just now you look at the lecture notes I already mentioned. If for at transfer stage, we only consider the cell weight, bin weight, and and also the due to the pre-stress force. Is it? Due to a pre-stress force. And start at transfer, initial pre-stress here, transfer here is 6,800. 6,800. So now at transfer, due the camber or deflection, outward deflection due to the pre-stress, this is the equation. So we substitute in. We substitute in side here. Okay, remember if you want everything in mm and Newton, then you substitute inside. So make sure the unit is consistent. So we substitute the P, L is 24 meter, E is 28, is it? And everything we are putting in. Only E here, you look at E here because it's 0. E is 0. So E is 0 and delta is 0.26 here. This is delta. Okay, so everything we substitute inside here, we get an upward deflection of 60.5 mm or 0.0605 meter. Okay, this is at transfer, means that you'll get an upward deflection. Okay, the beam will go up camber. Now under the vertical load, we have what? We have the cell weight, is it? We have the cell weight only at transfer. We haven't applied at transfer, we haven't applied the service load. Therefore, only consider the cell weight. So the cell weight is uniformly distributed load. So we apply 5WL power 4 divided by 384 EI. So we get a downward deflection. This is downward deflection. 0.0272. So the resultant is what? It's due to the pre-stress upward 0.0605 minus is upward and plus downward 0.0272, this one. So we get a negative value, upward 0.0333. This is the resultant at transfer stage. We get an upward deflection of 0.0333 meter, or 33.3 mm upward deflection. So allowable, we can use a span. You can base on in the design code, because we are calculating the deflection based on the exact value, how many mm. In your normal RC design, we simplify it. We assume it is a homogeneous material already in normal RC design. Therefore, it's composite. Sorry, it's a composite material in the composite material in RC design. So what we did is we based on M over BD. We based on L over D. We based on the L over D allowable and L over D actual to compare. But in RC design, actually, we can use this way to do it also, okay, to calculate, and then we limit it to what is allowable based on span over a factor. So the factor of 250, 360 or what is depend the structure itself, okay, depend the structure itself. If they say the structure is very putting a very fracture material, have some services or services of finishes is very ductile materials, not ductile material, fracture materials that easy to crack and so on. You may, this one you may go up to 360, okay, so that the allowable you will reduce it, the allowable. But in generally, you can use span over 250 as the allowable limit, okay. So okay, you less than the allowable limit. Now, as service ready, we have to consider the loss. The loss is it due to the pre-stress force 4,500. Now, instead of 6,800, now we reduce to 4,500 as service. So we substitute everything inside. It's only different here is the P. We change it to 4,500 kilonewton. Okay, 4,500 kilonewton. So we get an this one should be outward deflection. I think I have drawn wrong already. It should be the, please correct. I have do some correction here. It's the upward deflection shape. Okay. It's an upward deflection. It's an upward deflection. Okay. So after this, due to the vertical load. So due to the vertical load, now we have to combine together the cell weight plus the external load. So total is 41.26. 41.26. So total. So we get we substitute in the equation, we get an downward deflections 0.0995 meter. So resultant short-term deflection at transfer, not at transfer really, at service, at service, this is at service, at service, at service, at transfer, at service, at service. See here as it's only short term at service. This should be at service. Okay, at service cannot be at. Okay. It's a short term at service, but it's a short term at service because we consider the service load together. It's downward already. You see, just now it's still upward, but now it's downward. But it's still less than the allowable. Okay, this is the first example. Now we look at long term. Look at long term. I do say first. Look at long term. Okay, long term we have take into account the especially the creeps. Usually we ignore the shrinkage because the shrinkage usually is not as critical as creep. Shrinkage is shrink a little bit only. Okay, if we use a normal concrete, the shrinkage is not very much. It only will cause some cracks, this kind of cracks only, but not in terms of the deflection, you're not cause much. Okay, therefore we can ignore it. But creep is critical. Creep is because it deflects. Is it permanent load? We apply the permanent load for long term, then it may deflect. So creeps. So effect of creep may be estimated using a method that given in BS 810, whereby is either in BS 810 or Eurocode 2 whatever. But basically we can adjust, we can calculate the effective E modulus of elasticity due to the creeps based on this equation. Means that we consider the creeps. Is the effective E, okay, of the concretes, effective modulus elasticity of the concretes is equal to ECT. ECT is at the edge, okay, at edge, divide by 1 plus the creep coefficient. 1 plus the creep coefficient. Still remember when you are studying the losses that time, you have studied calculate the loss due to the creep, is it? And we have to calculate this value. We have to calculate this value. Okay, we have to calculate this value. So maybe I have attached this another page actually is during in the example. We have to calculate the effective sections, thickness of sections. Then we can calculate. There is a table, a figure that to estimate the creep coefficients. Okay. Then the E at 28 day, you see, the Young's modulus of concrete at 28 day is based on BSA1. Roughly, you can estimate based on something like this. Is 20 plus 0.2 FCU at 28 day. FCU is a cube strength. For example, let's say you have a value of grade 40 megapascal. What is the E? What is the Young modulus of concrete at 28 day? Approximately, average about is 20 plus 0.2 times 40 lah. 0.2 times 40 is what? 8, is it? So we'll get 28. We'll get 28. Okay, you'll get 28 here. Okay, so the total long-term deflection, is the delta of long-term due to pre-stressing, due to permanent load. Okay, it's the long-term delta LT due to permanent load. This one under the permanent load, and plus, okay, short-term due to total load under the total service load. Just now we already calculated short-term deflection under the service load, and minus this one is a short-term due to pre-stressing, due to the short-term deflection under the permanent load here. Why actually is something like this? This one will cause these two most of the time. You see, after this, in the example, but basically, you figure out after this how it's going to deflect. At the end, you'll get the idea, basically, you get the idea. So, is the long term due to permanent load, short term plus short term due to total load, minus the short term due to permanent load here. Okay, due to this one. So now we look at an example to calculate this to calculate the deflections, long-term deflections. Okay, determine the long-term deflections of the beam in figure example 1. Just now, still remember? Just now, this example. Okay, this example. Okay, we are going to calculate the long-term deflection already. Okay, long-term deflections. If 2/3 of the total service load is permanent, so we have to know how much we have to consider as the permanent load. Depend the structure actually sometimes. Okay, the total load, how much will become a permanent load? So in this case, you assume 2/3, 2/3, 2/3 of the total service load. Just now, the total service load is 40, how much? 41.26. So 2/3, 2/3, 2/3 multiply by 41.26. Consider 27.51, 27.51 as the permanent load, long-term permanent load. Okay, as the total, as a service load as permanent service load Okay, and assume SCU 40, 28 day, 40 megapascal, and the beam, let's say assume this is a rectangular pre-stressed beam, B and the H, this is a B and this is a H, and the cross-sectional area is basically these two, multiply it. So for long term, and also for long term 1 year, the FCU infinity will go up to, from 40 actually go up to 50 megapascal. I think this one we are not going to use. We're going to use it or not? Maybe not. I can't remember it because we have the equation. Because this one is, we have an equation, this one to estimate the infinity for long term. What is the E here What is the E here? Okay, so for at 28 day, we can use the equation 20 plus 0.2 times 20 FCU, is it? 28 day. So basically, how to get this one? EC at 28 day, 20 plus 0.2 times FCU 28 day. Okay, we get this one. So to get the we need to calculate the creep coefficient based on this one. Still remember, based on this one. Okay, to get the creep coefficients, we need to know what is the ambient humidity, and then the loading age, age of loading, when is it? And also we need to calculate the effective section thickness. Effective section thickness is 2A divided by the parameter, is it? So these are equations that you already look at it in the subjects, in the topics of pre-stress loss. So we substitute sections given already, B and H given. So we substitute, we get the section effective section thickness. Okay, effective section thickness, T effective. Then we go and based on this the table here. Okay, the table here, and then we can calculate what is the coefficients. If we know the what is the loading age, 28 day or what, then we can and the humidity if given, then we can estimate the phi here. But here actually given at the end, it give you a value here give a value. Assume this is 0.9 assume this is 0.9. Okay, assume this is 0.9. It may be bigger. Okay, here. Okay, from chart in figure 7.1, assume this is outdoor it is an outdoor. Okay, then you try to figure out to get the value here to get a value here 0.9. After this, we are going to estimate, calculate the, because we want to get the reduce the effective modulus of elasticity of the concrete at long term due to the creep here. So first of all, we calculate the EC, okay, of the concrete for long term. Basically, this is the equation. These equations are given in British standards, Part 2, BS 810 Part 2. In BS 810 Part 2. So basically, this is the equation 0.4 plus 0.6 FCU infinity divided by FCU 28 day. So this is given as 50. This is 40. So class, please correct it. This one, I think in your notes here got some mistake here. Okay. In your notes here got some mistake. Because when I go through again, I noticed that here got mistake here. If not, you cannot get this value. Oh, this is 50 and this is 40, is it? So we get 32.2. Then the effective section thickness here, effective Young's modulus of concrete here is the EC infinity 32.2 divided by 1 plus the creep coefficient. So become 16.95. Okay, you see the E already reduced. Initially the E can be 20 at 28 day. Is basically is 28. Now already reduced to about 17 megapascal for gigapascal for long term. Okay, for long term. So now we are going to calculate the to calculate the deflection for each one. Okay, the long-term deflection under permanent load, the short-term deflection due to total load service, and the short-term deflection under the permanent load here. Then this one plus this one minus this one, we get the deflection for long term. You hold a minute, sir. Hold a minute. Okay, no. So now we calculate the loading. Total service load just now, 41.26. Permanent load, just now in the question got mentioned, assume 2/3 of the total service load is permanent load. So this is 27.51. This is going to use what? In the long term, in the long term, due to the creeps. Effective pre-stress force, now long term, we use what? We really consider the loss, the losses, the loss is 4,500 here. So now we're going to calculate the long-term deflections under permanent load first. Okay. Delta effective, this one. We are going to use what? Because long-term is it? We are going to use the effective MOE of the concretes. Due to pre-stressing force, this is the equation, still the same equation. What the difference here is you have to apply what? The losses ready. The effective means the long, after consider all the loss, the P effective after the loss is 4,500. And the E, we are using the E effective here. E effective here, 16.95. The rest still the same. So we get and what? Outward deflections of 0.0662 meter, 66.2 mm outward deflections. And due to the critical vertical load, after this is due to the pre-stressing, and we have due to the vertical, long term is it under permanent load? Permanent load is it? Due to the permanent load is 2/3, is it? 2/3 just now we calculated 2/3, 27.51. So we substitute inside here 5W L power 4 divided by 384 EI. So we get an downward deflection 0.11. So the long-term deflections under permanent load is downward 0.0437 meter downward. Okay, downward deflection. After this, we are going to calculate the short term. Okay, now it's a short term really. Short term deflection total under total service load. This under total service load. Total load. Now the difference is the total load here. Okay, the P, now you see this is the difference here is what is it? The difference here is because we are calculating the short term. Therefore, the difference here is we are using the E short term at 28 day, E concrete at 28 day. So we get, but the P still consider really cause the loss. Okay. So we get an upward deflection, 40.1 mm upward. And due to the vertical load, total vertical load now is total service load 41.26, and E we are based on what? Based on the E is based on the short term. So we get an downward 99.5 mm down. So the resultant of the short term deflection under the total service load is equal to the short term deflection under permanent load. Okay, the E short term only, that's all. But it's under permanent load is here is what? We are only two-third as the permanent load. So we apply here, this is still the same, just now, the same thing. It's only here that the load already reduced, only consider as two-third, reduced as two-third. And this is using short-term E of concrete. So this one we get 0.0263 downward here. So now the total long-term deflection is the long-term due to permanent load, short-term due to the total load, and the short-term due to the permanent load, where the permanent load is two-thirds only of the total service load. So therefore, at the end, we get an downward deflection. Positive is a downward deflection 0.0769, which is less than L over 250. L over 250 we calculated before. L over 250 is, what is the value? L over 250 is 0.096. 0.096. So this one we get only for long term. What you get is 0.0769. Okay. So your design, after you have designed, if you are using post tension you need to design the M block. Then after the M block, you have to design for check for the deflection. If you are design using pre-tension, you no need to design the M block in the project. Okay, if you are using pre-tension, but you have to calculate the debonding. What is the length of the debonding at the end span? Okay, so this is the second example. The third example actually is the difference here is only it become a parabolic. Okay, a parabolic equation. Okay, parabolic equation. But the process is the same. If in this one calculate the deflection for the beam below, it did not tell give you very clear. You can in your example, in your project, you can based on like this to calculate. You can based on this example number 3 to do to check for your deflection. I think it's sufficient. It's sufficient. Calculate deflection for the beam below. Data given below. Size beam, this one. Cell weight like this. I given. ECI given. This is at transfer. EC also at transfer and the long term, it means at 28 day we use the same E. Okay, live load 20 kilonewton per meter run, and the initial pre-stressing force is 2250. Losses 25%, and the creep coefficient assumes is use 2 Okay, use 2. And you look at here, the E is 0, and the mix span is 200 and 210, and the span is 10 meter. Due to pre-stress, okay, due to pre-stress at transfer, as just apply only, is it P at transfer, so we did not consider the loss here. Okay, we substitute, but we are using the palette, the camber, or the pre-stress, the deflection due to the pre-stress here. And after this, the vertical load transfer only due to the cell weight. So substitute in, we get a downward here. So resultant short-term deflection at transfer is what? Is this one upward plus this one. So we get an upward deflection. And check for the allowable. Span 10 meter over, is it 10 meter? Huh? Is it 10 meter? I don't know whether it's correct or not. It's 10 meter. Huh? 10 meter divided by 250. Is it correct? 10,000 divided by. I think has something wrong here. Huh? Class, huh? I think have some mistake here already. Huh? Never mind, like, just adopt it only lah, huh? You just adopt it only. You see, this is 10 meter. Huh? I think this one got some. This one is not pass actually. Is it pass or not? No, it pass. 0.04. Huh? This one is 0.04. 0.04. Okay, 0.04. 0.04. I make the mistake. Span is 10 meter, is it? So now at service, okay, we just consider at transfer and at service actually is sufficient. Yeah, at what you need to do lah, in your projects, Due to pre-stress, now at service we consider the loss already 25% loss, is it? So left only 1687.5 kilonewton. So we apply here, apply to the equations, the same equation, but E also at service also the same. Okay, the E same. It's only a substitute. We get an upward 0.0077, and due to the vertical load, now total service load lah, vertical load 7 plus 23 plus 20. This is given 23 plus 20 is given, is it? 23 plus 20. Unfactor load remember unfactor service under SLS Okay, so 50 kilonewton per meter run for it. Okay, this is 0.04. 0.04. I make a mistake. So please correct it. 0.04. So we get an upward deflection. Both case under service also, but it's short. Under service also, both are actually we get upward deflection. Okay, I think maybe I got some error here, may have some mistake. Please, I have corrected some already. So we have finished the these deflections. So we open for the Q&A. We open for the Q&A if you have any question. Okay. Okay. So any questions or not? Can you get it, class? 28 students here. Do you have any question? Can you get the what we have discussed just now? Class, can you get what we have discussed just now? If you understand, can you please comment 3, so that I know you will understand what we discuss. We go a bit fast, we go a bit fast. Okay. Okay, good. All comment 3, So no questions, If no question, we are going to we're going to have so many messages come in. Where let me check. Nanti tanyakan member kat fakulti. Aminat, ada pertanyaan dari pihak luar. Travel advice on international students. Okay. Got so many the link like the children all school So don't know why cannot go to school, uh, but they allow the kindergarten to go to school. Okay, but why like from one the rest cannot go? Why you don't want to do alternate or what? You already let the kindergarten can go, is it? Why the rest cannot go? I really can't understand. You don't want so many, maybe you can put as alternate. Wow, you are totally in online, especially for the lower secondary and the primary school. If the parents are not no time to take care to look at them, actually a lot of problem will come out. You have missed 1 year. I don't know what happened. Education is very important. So if we got guide them, guide our children, at least they are not miss out a lot. Okay. But if that say you got at least you got go for physical class, not the whole weeks, 2 days, 2 or 3 days per week, alternate or what. At least go there, then you still have to. The teacher can give the assignment or homeworks to do, and they can submit and so on. If it's online, don't know what they are doing. Okay, and not all teachers are good in have this kind of skill also. They are facing problem also. Okay, so that's why I so really cannot understand. Okay, so now we go. We are not going to take 5 because we have tried to finish before 11. We go for the last one, which is the composite constructions. Okay, go to the last one. That but I focus actually the last. I just go maybe the example. I'm not going to show you in detail. Give you an idea how is it. Okay, in composite construction. So I'm going to share the screen now. If you want to do recording, I can do the recording for you. We wait for the recording to start. Okay. Okay, good morning again. We go to the last one, composite pre-stressed beam. Composite pre-stressed beam. Composite pre-stressed beam, or it can be not necessarily the beam. It also actually apply to like slab and so on. But most of the time, we talk about composite here. You may think composite is two material, but in the like in pre-stressed concretes here, we may not use two material. Is the material here is both are concrete, is it? Both are concrete. It's only the methods of construction. The method of construction, like what at the beginning of today class, I have shown you the composite beam in precast composite beam. Okay, precast composite beam. So you see, both are actually concrete. Both are concrete. It's only depend on the construction methods. Okay, we have combined cast in situ and in the pre-stress in here, similar to precast, we have precast plus cast in situ concrete. Then we combine become a composite action here. Okay, composite construction implies the use in a single structure acting as a unit of different structural element. Means that we combine here become one. Okay, make with similar or different structural material. So it can be different or same material. Like you study in steel design, you can have always have steel combined with concrete. So we call it a steel concrete composite. Or you can have a timber beam and top is a concrete. So we can have a timber concrete composite. Even we can have steel beam on top is a deck. You can using for example that says steel deck. So we can timber steel deck. But we can that is the different material. We combine it become one composite material. Or you can have using the same material, some sort like in the precast concrete structure. It is based on a precast concrete structure, the beam as a precast beam, precast concrete beam, and then we cast in situ the top, the slab, then become a composite here. Okay. So in a composite, remember, where only concrete is used, as just now I mentioned, as a material, the concrete is placed in at least two separate stages, as just now I mentioned, precast and cast in situ. So this is the case of composite made with precast reinforced or pre-stressed concrete. You can be the precast, you can be pre-stressed or normal reinforced, and then combined with a concrete element cast in situ at a different time. Okay, at a different time. Many applications of pre-stressed concrete involve the combinations of precast precast pre-stressed concrete beams and cast in situ reinforced concrete slab. These are widely used in the market. These are widely used in the market in the constructions. And I can say this kind of construction has become more and more popular, especially if you want to go for long span constructions. We want to make sure we want to reduce the workers. We want to reduce some of the formwork and want to increase the time of erection, times of constructions, and reduce the rubbish or construction waste, especially. So we can use this kind of constructions. And also another one is we want to claim for the IBS system, IBS score. Okay, we use precast. So this is some of the example: slab and girder. Okay, so cast in situ on the I-beam. Okay, we can have the some sort like pre-stressed plank. Okay, the hollow core slab. Then we got cast in situ topping, become a composite, and we can have T section. Okay, this is a T section, and top is a cast in situ, and we can have a double T. Okay, and cast in situ. So these are the common composite structure that we use in pre-stressed concrete. Okay, what is the advantage? Actually, what are the advantage we use? Okay, I can say the advantage in terms of the time. Okay, in terms of the times, and also workers. If we are shortage of the general workers, construction workers, and then we cannot like in MCO or what now. And if that say in Malaysia, our ringgit is weak, and other country their currency is increased. So actually we are difficult to get the workers. Last time we can say from China, for example, in China, the mass production can produce a lot of coming import the workers from China and so on. But now you see where you can get it. Indonesia, one day also we want to export workers, not import the workers really. So one day if our economy, our currency is not compared to other countries, they have overcome us, so there is not attractive to for others people come here to work really, especially for this kind of general works. So what to do if we have to reduce? We have to reduce. One way is go for IBS to reduce workers, is it? To reduce workers. So time is one thing, because why? We are no need to erect the formwork and so on. Less of the scaffolding, less of the formwork. The beam, the precast beam, the precast slab, okay, or half slab will become the temporary structure already. Temporary structures. Actually, I always say the precast and pre-stress actually should be grouped in together. If you offer, it's like most of you studying these two subjects together, that will be the best. You are become more focused. Elective, is it more focused? When you go out to work, if you work in precast and pre-stress, all interrelated, you will have the advantage in your CV, have some knowledge. That's why in the next semester, however, next semester pre-stress, precast is not offer. This is the first semester offer. You the pioneer. I got told the what the health department supposed the last time when offer the subject of elective going to offer for next semester, ask my opinion. I say if you really want under IBS, Even if you are not offering pre-stress, even the precast you can offer precast even better. So if I still the same, I'm the person to teach, so I can when teaching the precast at time, I can take some of the parts important things in the pre-stress concrete that putting in the precast when I teach at time. If that's a elective 1% only is it, I can adjust. But however, no lah. So only offer pre-stress, only pre-stress and 2% to teach. But I'm still the main person to teach. Okay. So pre-tensioning in plant is more cost effective lah. Yes, than post-tensioning. And why we say that composite? Tension we can do it in the factory. Okay, at the factory we can have a mass production and so on. So in terms of cost production, we can reduce the cost. Therefore, we can have pre-tension structures and then bring to the site, and then only we can pour the topping, become a composite sections. So these are the composite construction become effective in terms of cost. We can reduce some of the costs and so on. And also just now as the form of the formwork, is it the formwork I already mentioned just now? In terms of the formwork, you can reduce the formwork. And composite also, the advantage in terms of structurally is what? If you consider composite, actually the effective section really increase. In terms of stiffness really increase. Therefore, it become more effective. Like just now I show you in the composite beam. You see when the composite action taking place, we can consider the section really, the overall section really increase. The I will increase. The section modulus will increase, and the strength will increase. Okay, that is the means what another advantage of the composite construction. And also the cast in situ slab can be poured continuously over the support of precast unit placed in series. So therefore, providing continuity to a simple span system. Yes, easy for us to cast the concrete. We can achieve rapid construction in it. And if we not cast it in many stages, actually we can reduce all the joint and so on. And always cool joint is to cause the problem of crack and so on if you have many joints in it. So now we can reduce the joint on the topping. So analysis here, I'm going to go brief to you very fast. I want to focus actually more on the horizontal shear. Horizontal shear. That one I think is important because in the precast concrete also, last time I have skipped a bit, but you can use this what you're studying here to apply in the precast concrete in the horizontal shear. Analysis of composite section depend on the type of composite sections, the stages of pre-stressing, and the types of construction, plot or unplot here. A precast member is supported by plots, okay, along its length during casting. So we call it as a plot. If they say, if the precast member only supported at the both end only, so we consider as unplot, okay, as unplot. So, and these are the loading stages that we have to, as a sequence, the sequence. In show and unshow actually is considered as a plot and unplot. Okay, plot and unplot. So we have to divide it into three stages. Okay, the first and second loading stage is under the precast. Composite action haven't taken place yet. Okay, this is at the transfer stage. At the transfer stage, we only consider the PI and the loss is a short-term loss. Okay, the short-term loss and due to the cell weight. Okay, for both plot and unplot. And for stage number 2 here, okay, is that say is plot, we only consider the loading the same as plot as the stage number 1 at the transfer, but we can but the P here is the long term already. P we can consider as the long term loss. Okay, here if the loading we have to take into consideration. If they say unplot, we have to add the load due to the slab already. If you pour it already, okay. But because we got plot, show here is considered as a plot, means that we can consider the slab, the loading is already carried by the plot. Therefore, we did not consider in this case here. So when composite action, the concrete will pour ready taking place. Okay, it form as a composite action really taking place. So these are the loading. Both are the same. The loading that we need to consider are the same here. Okay, for both cases, plot and unplot. So you can see when you analyze that time, we look at the stress at time. This is at transfer stage. Okay, this one haven't taken place. The topping here haven't taken place here. Okay, loading stage 1 and loading stage 2 here. Either we need to consider the slab, the loading on the slab or not. But these are the this is at transfer stage. So at service stage, you have two. One is plot and unplot. If they say unplot here, you see unplot here, the difference here at the slab here, okay, the slab M slab here is different here. So it's something like this is from here, okay, then combine become like this. But if they say plot, especially the slab here, we can take until here. If plot here, we can put until here already. Okay, so become like when you this one plus this one plus this one, okay, become this one. But this one is, you see on top here, this only this one, is it? Due to the live load here. Okay, but you did not consider this one. Okay, this is the different plot and unplot. So we have and after this, the from all this actually the stress distribution here, okay, we have the limiting stress. We want to limit the stress, and F prime mean under the tensor. F prime means we got the tensor at transfer, okay, for different type of pre-stressing. Okay, in class 1 member, if they say class 2 pre-tension, class 2 post-tension, and under the compressive stress, okay, compressive stress F prime max, allowable stress. This is for fracture fracture member near uniform distribution of pre-stress and so on, something like F prime min and plus F prime max. Okay. Okay. So and then we got stage number 2 and stage number 3 and these are the for the allowable stresses. Okay, this is at transfer. Okay, tension and compressions apply. Then for service stage, F min and F max, something like this. These are the value These are the value allowable stresses. So from here actually we can go back to the normal, go back to the fundamental. We can actually come out the tabulate out the equation at stage number 1, stage number 2, and stage number 3. Okay, stage 1, stage 2, and stage 3, and also limit the stresses. And then from here, it means the inequality equation, is it? Inequality equation. And from here at the end, actually we can form out the equation. If we want to design based on composite, we can actually come out the equation for Z1, Z2, and use for the rest also the same thing. We can further develop for the pre-stressing force for the Magnum diagram, the equation for the Magnum diagram, like what you have learned in the without composite situation. Okay, so these are composite, and there's example to have provide you an example. You got time, you want to read, you can read by your own. Is to get the stresses here, as I already mentioned here. There's now all the stresses value here for at different stage. Okay, the stresses at 3 different stages here. Okay, there's example given here. Okay, example given here because we are not sufficient time, but I just to give you an idea about this only. Give you an idea about the composite here. If you're looking, go back to, you want to design based on composite everything we can do that also, but use the same thing, but we have to derive another set of equation. Okay, another set of equation. There is the example here. The stress at stage number 1, stage number 2, and stage number 3 to get at the end the stresses, and then we have to check the stresses. We have to check all the stress, allowable stress. Okay, as just now given the equation. Okay, this is a little bit about composite. So there's the last thing that I would like to discuss is the horizontal shear. No, not this one. This one suppose is horizontal shear. Okay, just from the books, just from the books here. Okay, you see a composite. When you talk about composite here, it become a composite taking place. When composite really taking place, let's say this is a precast. This on top is a cast in situ. Cast in situ. Okay, let's say something like this. Maybe it's reverse. It's okay. You see, precast and cast in situ here. So basically, if you composite really taking place, both are combined, is it? If you deflect, both will deflect together, is it? Both will deflect together. You're not going to separate. You're not going to separate. You're not going to separate it. So basically, when you deflect that time, what happened? You cause the horizontal shear here. Have the horizontal shear here. You cause the horizontal shear, something like this. Okay, this one. Okay, something like this. You're going to have a horizontal shear. Okay, because you're going to deflect together, you must have a shear, horizontal shear. So this horizontal shear we have to take into account. If not, you are going to separate it between the two layer in the bonding, the interface, top layer, bottom of the top layer, and the top surface of the bottom layer. You cause there is a shear, horizontal shear stress here. So we are going to BSA 110 we provide the equations to calculate the horizontal shear. We direct go to the example. We direct go to the example how to calculate the horizontal shear from this example. I have posted actually precast concrete design, the link I think have already posted in the another Google Classroom. But however, if that say we no need to go to the another class, you can use here. We direct from here. After you take a break, I think we no need to create another Google Meet link. We're not going to use the Google Big link in the precast that I have already posted because I already schedule actually. Use a calendar to schedule, but we just remain here. We just follow here. I'm not going to close it. So we look at the example. Determine the horizontal shear stress. At the end is to get, we want just now the beam or the slab here. Let's say it's a beam. It's the beam. Let's say it is whatever size of shape of the beam. That the link that we're going to project it out. Okay, we have two methods to provide the link. One is like this. One I will show you after this. Or sometimes we may put like this. These are the link. Okay. Here very windy today. Also yesterday also the same thing. Very windy. That I even did not on the fans also. Okay, so you look at here. These are the two type of horizontal shear link that we're going to arrange. Either we can arrange like this, projected out actually the same as what you design in your shear link. then you can check whether this is sufficient for the horizontal shearing or not, to resist the horizontal shear stress or not. Okay, or you can do like this, or you can do this way. Okay, these are the two detailing of the link widely used. Okay, there's actually another one, you can bend that one and bend to the side, but either this one or this one I think widely used. Okay. Okay, so now we look at an example. We have a cross section something like this. Okay, bottom parts, this is I-beam, and on top there is a thickness here of the cast into slab 180, and the effective width here taking as 1500 lah. We can be actually center to center. We are going to arrange the beam here, maybe every 1500, 1.5 meter we have one beam, so we can take interval like this, take this one effective here. And the contact here, remember here, the contact between here, the interface here is depending on the top width of the beam is 300 here, 300 here. And the beam along here, the beam is 20 meter, 20 meter, 20 meter. Okay, 20 meter span. Assume that at the ultimate limit state, the neutral axis of the composite section lies below the slab, Okay, we have to make sure that one. Okay, everywhere along the beam, and the FCU, okay, 28-day cube strength 30 megapascal. So first of all, what we need to do is we are going to calculate the total the horizontal shear stress. Okay, there is an equation actually given in the British standards. In the British standards, the horizontal, it just described only, it just mentioned only, is the average is the horizontal. I think it's here or not. I mentioned here or not. Horizontal stress. I don't know whether it's mentioned here or not. Okay, it got mentioned actually how to get lah. Okay, in either case, the average, this is already reached already. Okay, the horizontal shear force should be taken as the compression force in that parts of the zone which is above the interface. So therefore, we assume actually the neutral axis lies below the slab. In that case, the average and so on. Never mind, let's look at here. There is an equation there. There is an equation there. Okay. So the first of all, we need to calculate the total force in the slab. Is all total force is under what? Compressions. Compressions. So the equation is 0.45 FCU. If you're using Eurocode, actually 0.567 FCK lah. So 0.45 FCU multiplied by B and the H. Okay, 0.45 means 0.45 FCU multiplied by B and the H, the total, consider this compressions, compression force of this slab here. Okay, then the average horizontal shear stress is given by the equation. The average, the V average is the total force divided by the what? Half of the length multiplied by the contact here. Multiplied by contact means here up to the mid length. This is the average. Average, the average is mentioned in the code It's something like L/2 multiplied by the contact here. The total force, total compression force divided by half of the length, because the length is 20 meter, half this average, remember this average, and half length multiplied with the contact. So we get is 1.22 megapascal. And this one is what? Is average. Average means maximum horizontal shear. Just now I mentioned always have maximum is something like vertical shear. Maximum is at the mid span. Maximum is at the mid span. No, maximum at the end. Sorry, maximum horizontal shear is at the end. It's something like the beam, along the beam now you get is something like the horizontal shear. Like what you get is maximum here. What you get? So this is average. You get the average here. This is the V average. Average. VH horizontal shear average. VH average. Average is 1.22 megapascal. It's something like this, the value here. So this will be 2. The value is this value will be 2 times 1.22, 2.44. I stop sharing so that you can look at it. Okay, something like this. So we get just now, we calculate is the average. Maximum at the end, the horizontal shear. Okay, maximum at the end. And average, what we calculate is, just now we get is the average. The average 1.22. So average is something here. So the maximum at the end span is 2 times 1.22 lah. 2 times 1.22. That's why for those who are doing research in the composite, we need you study in shear in the steel concrete composite. We need design the shear stack. Okay, we need more shear stack, more closer shear stack at the near to the end here. So therefore, why from here you get the I think it's full already. This one full charge already. Okay. Therefore, you get the average. Therefore, after this, you get the maximum. You get the maximum at the end here. It's 2 times 1.22. Why 2 times 1.22? From the diagram, I already show you. From the diagram, I already show you 2 times 1.22. Okay. So now, so this horizontal shear stress, this is the design maximum horizontal shear stress. So we have to check whether this one we need to provide link or not, or just put on top of it really sufficient. Okay, so we have to check that in the standards we have to have the allowable. Okay, in the standards code of practice BSA 110, it provide the allowable. Assume, for example, this is the allowable ultimate horizontal shear stress. Okay, if let's say the maximum horizontal shear stress is less than the allowable, so theoretically we no need to put extra link. We no need to provide the horizontal shear link. No need to provide the link to receive the horizontal shear stress. However, if let's say the horizontal shear stress that developed due to the composite action is greater than the allowable, therefore we need to provide extra link. Okay, link to take the horizontal shear force. Okay, shear stress. So assume in this case, normally as cast or as extruded means that like just now the detailing, we are going to cast it, the link cast it in the beam and projected to the to the slab, cast into the slab. So these are the allowable shear stress. Just now we use cast concrete grade 30. So therefore we based on X cast, and the allowable that we're going to use is 1.8. Is allowable ultimate horizontal shear stress at interface is 1.8. So however, our in these questions, the horizontal shear, maximum horizontal shear stress is 2.44, which is greater than 1.8 allowable. Therefore, we need to provide the link, the horizontal shearing. We need to provide the horizontal shearing. The amount of steel required is because 1,000, because we design for based on 1 meter, based on 1 meter. B, okay, B is the contact between that two cast in situ and the and also the precast beam with the width of the precast beam on the top is 300, okay, 300, and this is the horizontal shear stress divided by 0.87 FYB lah. And what is the steel, the link, the strength of the steel reinforcement, the link that we're going to use? It's 250. In this case, 250. You can use 460. Okay, you can use 460. In bridges, I think we always use 460 or 500 high yield steel we use high yield steel. So then apply, we get required is 3,366 mm square per meter run. Okay, per meter run. So now you are going to use what is the spacing? Okay, you are going to use 16 mm. R is represent for FYV 250 mild steel. So 16 mm, what is the 16 mm? 16 mm is what? The AV, you got 2 shear leg, is it? The leg is 2, is it? So 16 is 201 times 2 is 402. So 402, 3366 divided by 3366. This is the required. If we are going to provide R16 115 mm, what is the provided? R16. R16, the AS is what? AS for horizontal or for the link. If we use 16 mm diameter, the AS will be what? ASV or ASH in this case is 2 times 201, is it? We get 402 mm. And we are going to provide the spacing R16 spacing 115. So the AS provided AS provided here will be what? 402 times in 1 meter run divided by 115. You'll get is after this I will show you 402 times 1,000 divided by 115 we get 3496 3496 3496 per meter run. We require 3366. So something like this. Or it's over a bit the time. It's okay already. This who, if you want to go for another class, I can go already. So almost finished already. So like this is we are going to provide 16 mm because for 2 leg 402 201 16 mm is 201 402, and we are going to provide a spacing 115. So substitute inside here for at 1 meter. Okay, we will get the provider is 3496 and required 33 something, is it? Required 33 something. So required 33 something. Required 3366. So R16 we can 34, we provide a bit more 3497. After this, the minimum, okay, the minimum, the nominal reinforcement or minimum reinforcement is about 0.15%, 0.15%, okay, 0.15%. Although we say that if theoretically, if let's say the horizontal shear stress is less than the allowable shear 1.8 megapascal, we no need to provide, but we're still going to provide a nominal link. So the nominal link is the okay, the spacing of link in T section should neither nominal link is 0.15% of the contact area, 0.15% of the contact area that is which is required 450 mm square per meter run. But the spacing of the link in T section just now become a T section should neither exceed 4 times the minimum thickness of the slab. So the thickness of the slab 180, is it? 180 times 4 or 600 mm, whichever is lesser. So the spacing of the link you have to maximum spacing that you can go is 4 times the thickness of the slab or 600 mm, whichever is lesser. So in this one, for for minimum we require 450. If 450 we still maintain a 16 mm link. If you can go, we can go up to 600. 4 times 1 720 is go 600, greater than 600. So we provide the rest is going to provide 600. R16 600 is what? How much? R16 600 is the provided is 42 times 1000 divided by 600, which is 670. Okay, this one R16 600 is 670. 670. Okay, comply the maximum spacing and complies also the minimum, the required here. So at the end here, actually we are going to provide something like this along the beam, something like this. You can this is 2.44. This is 1.8. Okay, so at the end is something like this. At the end is at the both end from 2.44 the horizontal shear stress up to 1.8. You provide for both end. You provide R16 115, and after that over the 1.8 you just provide nominal link R16 600. Okay, so these are the link, the horizontal shear link. Then you can compare like what you design in your vertical link that you're going to project it out. Is it comply that one or not? Whichever is critical, then you can decide your link that you're going to provide, the vertical link, because it's still using the vertical link that you're going to project it. Is it sufficient to take the horizontal link or not? Horizontal shear stress or not? Okay, so at the end, the last one is as I already showed you just now, the detailing. Okay, one is like this. One is as just now I mentioned to you. I will go up, left and right, or we can actually bend this two way. Okay, bend like this and bend like this. This is the connection between that two. So class, I think we already finished out. Actually, we have finished out the syllabus for the pre-stress. You see, we can finish out the syllabus, no problem. I know I teach it many semester. This subject I have teach it, I got teach it before already. I know which one have more, which one is less, but I go a bit fast. So we before we end, we go for a Q&A, because after this we are going to not start immediately. We got the time. We go take some food, we can rest for, we start at now has about the time 11:12. About 11:30 or 11:30 plus a bit, then we'll start with precast concrete design. So we go for Q&A. If you have any questions, I can stop the recording already now. I stop the recording. Okay, so any questions? Before we end out the pre-stress class. Okay, class, do you have any questions? You can post your questions, or you can on the mic and ask, or you get it or not. especially the composite construction. I go a bit fast. The example I did not show you. I just to show you the concept of composite constructions. We can come out the inequality. It's only composite construction. We have to have 3 stages of the loading, and the E actually when you go to composite constructions, when you calculate the I, we have to calculate the spatial I. To calculate the stress, we have to calculate the I, the composite I, the I, you're going to I basics plus ax square or ad square. You have to use the I of the beam, I of the beam plus on top composite. This is a beam. This one is of the slab to the distance of the resultant. You have to get the resultant. Go back to your static dynamic to calculate the I composite. This one. Okay. So in composite, you have to use this I. Calculate the when under the composite action, you have to calculate the I. The I will increase, as just now I mentioned to you lah. Okay. So then after this, we have discussed what the horizontal shear I think I have covered all already. At least touch all Maybe some I not go in depth, especially the for the en bloc design, because en bloc design we need have others methods, beam analogy and the strut and type methods. I did not touch on it. Okay, but I think the rest I have covered it. I believe maybe some of your subject, maybe you are here only focus on the elective. Another elective, I don't know you have finished your syllabus or not. Okay, but we did not miss any class. I think we did not miss any class. Okay, so if you understand what we have discussed, maybe you can comment 6. Comment 6 so that we'll end out for the pre-stress. Then we take a rest and we'll come back to continue with the precast. Okay, is it okay, or you got question? You can post out now your question. So you can comment 6 if you are understand. Okay, Celine got asked, sir, the modulus of elasticity in EC2 user mean yes, that one is because the equation we use different code of practice. It provide you different. It will give you a little bit of different value. Yes, in Eurocode we have his own equation. In table, can't remember already the table. In there's Eurocode, they provide you the estimate the Young's modulus of the concretes. Yes. There's but value will come out a little bit different. Okay, you'll get the different. It's only different equation. Okay, and the Eurocode is based on the cylinder. That one is cylinder, is it? But Young's modulus is for concrete. Is not only for based on cylinder or what, based on the grade of the concrete here. It's only I prefer in British standard is much easier to estimate it, the Young's modulus. Okay, but both are also okay. Both are also okay. Okay, yeah. So other people, can you get it or not? If you get it, then you can please comment 6. Then we can take a break. You can take some fruit or what you want to eat, some food, or you want to go to washroom. I need to go to a washroom and so on. Okay, then we come back. Okay, so now I think majority comment 6. So for the pre-stress, next week we still have the class. But next week is we will not go long. Next week is we discuss about the final exam. We discuss the final exam and whatever thing we want to discuss, and out of the these topics of the pre-stress and precast we can discuss. Okay, so next week I will tell you when the time only not very long, but maybe you can start a bit late also, no problem. Okay, or say that about 9 o'clock we will start the class, but I believe we'll maybe just go for 1 hour. When also next week maybe we can get ready so that we can have a camera. You get ready your camera. We can have a group photo lah. Then I can record it. Okay, for our that means for to keep it as a history next time become a history or what lah. Okay, we go for this pandemics and we go for norma baru, okay, the new norm, to conduct the class, to having your study, okay, as a good experience for us, for all of us, okay, as the lecturers, as the teachers, and as the student, you learn the process, okay. So I see you later. We take say 15 to 20 minutes, then I just leave it the computer like this here. You no need, you want to go out first, leave first, then you join back using this Google Classroom. We are not going to use the Google no, the Google Meet. We use this Google Meet. We are not going to use the Google Meet link in the precast that I already created, already posted. Okay, so I see you shortly. Okay, see you shortly. Yeah, thank you.